So, you've got a big construction project ahead, but what's beneath the surface? Today, we're diving into the world of soil investigation, assessment, and testing, the foundation of all great builds. Ever wonder why some buildings stand the test of time while others crumble? It's all in the groundwork, literally. By the end of this video, you'll know not only how to do soil testing the right way, but how to do it better, safer, faster, and at less cost. Stick around because we're not just breaking ground, we're breaking myths. Let me tell you a story, a construction legend, if you will. A seasoned engineer once said, "Your building is only as strong as the ground it stands on." Those words couldn't be truer, and here's why. When we start a project, soil investigation is where it all begins. Imagine this. You're on site with your hard hat and clipboard, and the first step is site characterization. This is where we dig deep, literally and figuratively. We analyze the soil's physical and chemical properties to ensure it's suitable for construction. Why? Because no one wants to build on ground that shifts, cracks, or sinks. Pro tip, use geotechnical software to speed up analysis and reduce human error. A solid site characterization saves you from costly mistakes down the line. Next comes borehole drilling, the backbone of soil sampling. Picture a rig drilling down to uncover the secrets of the earth. This gives us samples at different depths, revealing the layers we're working with. Here's a hack. Schedule your borehole drilling during dry weather to avoid waterlogged samples, which can skew results. Time it right, and you'll save both money and headaches. But we're not stopping there. Geophysical surveys are the X-ray of the construction world. Instead of breaking ground, we use tools like seismic refraction to map the subsurface. Think of it as non-invasive surgery for your site. Hack. Combine geophysical surveys with boreholes for a comprehensive picture. It's faster and more reliable. Ever heard of cone penetration testing, CPT? It's like giving the ground a strength test. We measure soil resistance to penetration, revealing its load-bearing capacity. This method is quick, cost-effective, and ideal for time-sensitive projects. Here's a tip. Use automated CPT rigs for consistent results and fewer manpower costs. And finally, trial pits. Simple yet effective. A shallow excavation allows us to visually inspect soil layers. Want to make it better? Mark your pits clearly and ensure the safety zone around them is up to code. This prevents accidents and keeps your team safe. Once the investigation is done, we move to soil assessment, where the real decisions are made. First, we evaluate the bearing capacity. Picture it like testing a chair before sitting. You want to know it won't give out. A quick tip. Use advanced simulation tools to model loads on different foundation designs. It's faster and saves money on unnecessary reinforcements. Then, there's soil classification. We figure out whether you're dealing with clay, sand, or silt. This predicts how the soil behaves under stress. Remember, clay expands and contracts, while sand stays stable. Knowing this helps you choose the right foundation type. Don't forget groundwater analysis. High water tables can wreak havoc on stability, so always test for it early. A seasoned engineer once said, "Design your drainage system like your budget depends on it," because it does. Soil stability analysis ensures you're not building on a slope destined for a landslide. Always factor in the risks of erosion, especially if your site isn't flat. And finally, environmental impact assessment makes sure your site doesn't have hidden contaminants that could harm the environment, or worse, your project's approval process. Finally, we come to soil testing, the technical heart of site preparation. Moisture content testing tells you if your soil is too wet or dry for compaction. Here's a time saver. Use portable moisture meters for faster readings. Proctor compaction tests reveal the soil's optimum density, ensuring stability. At the same time, Atterberg limits tests measure the soil's plasticity, basically, how much it can stretch without breaking. It's like testing the elasticity of a rubber band. Tip: conduct these tests on site for immediate adjustments. For safety, don't skip the shear strength test. It shows how resistant the soil is to sliding, crucial for foundations and retaining walls. And lastly, the permeability test ensures proper drainage by measuring water flow through the soil. A seasoned pro will always say, drainage is key to durability. Don't skimp on it. So, there you have it, the essential guide to soil investigation, assessment, and testing. By understanding your site's soil, you'll build safer, faster, and smarter. Remember, the ground beneath your project is its silent partner. Treat it well, and it will support you for years to come. Want more expert insights? Subscribe to Building Construction Buddies and hit that notification bell. Check out our other videos for tips and tricks to take your construction game to the next level. Let's build better together.